SC Fundamentals 1. Software Processes. CS708 January 29, 2013. SC Fundamentals 1. Software Processes. Ian Somerville. Software Engineering, 9th edition. Pearson Education, Addison Wesley. Note, these are a modified version of Chapter 2 slides available from the author's site http://www.cs.standrews.ac.uk/if/books-sc9/. Chapter 2 Software Processes. Chapter 2 Software Processes. Topics covered. Basic software process models, 1, 2, 3. Process activities. Coping with change and additional software process models, 4, 5. The rational unified process, 6. Chapter 2 Software Processes. Chapter 2 Software Processes. The software process. Software process, a structured set of activities required to develop a software system. Many different software processes but all involve specification, defining what the system should do. Design and implementation, defining the organization of the system and implementing the system. Validation, checking that it does what the customer wants. Evolution, changing the system in response to changing customer needs. A software process model is an abstract representation of a process. It presents a description of a process from some particular perspective. Chapter 2 Software Processes. Software process descriptions. When we describe and discuss processes, we usually talk about the activities in these processes such as specifying a data model, designing a user interface, etc. and the ordering of these activities. Process descriptions may also include products, which are the outcomes of a process activity. Roles, which reflect the responsibilities of the people involved in the process. Pre and post conditions, which are statements that are true before and after a process activity has been enacted or a product produced. Chapter 2 Software Processes. Plan-driven and agile processes. Plan-driven processes are processes where all of the process activities are planned in advance and progress is measured against this plan. In agile processes, planning is incremental and it is easier to change the process to reflect changing customer requirements. In practice, most practical processes include elements of both plan-driven and agile approaches. There are no right or wrong software processes. Chapter 2 Software Processes. Software Process Models. 1. The waterfall model. Plan-driven model. Separate and distinct phases of specification and development. 2. Incremental, exploratory, development. Specification, development and validation are interleaved. May be plan-driven or agile. 3. Reuse-oriented software engineering. The system is assembled from existing components. May be plan-driven or agile. In practice, most large systems are developed using a process that incorporates elements from these modules. Chapter 2 Software Processes. Chapter 2 Software Processes. 1. The waterfall model. Chapter 2 Software Processes. Waterfall model phases. There are separate identified phases in the waterfall model. Requirements analysis and definition. System and software design. Implementation and unit testing. Integration and system testing. Operation and maintenance. The main drawback of the waterfall model is the difficulty of accommodating change after the process is underway. In principle, a phase has to be complete before moving on to the next phase. Chapter 2 Software Processes. Waterfall model problems. Inflexible partitioning of the project into distinct stages makes it difficult to respond to changing customer requirements. Therefore, this model is only appropriate when the requirements are well understood and changes will be fairly limited during the design process. Few business systems have stable requirements. The waterfall model is mostly used for large systems engineering projects where a system is developed at several sites. In those circumstances, the plan-driven nature of the waterfall model helps coordinate the work. Chapter 2 Software Processes. 2. Incremental, exploratory, development. Chapter 2 Software Processes. Incremental Development Benefits. The cost of accommodating changing customer requirements is reduced. The amount of analysis and documentation that has to be redone is much less than is required with the waterfall model. It is easier to get customer feedback on the development work that has been done. Customers can comment on demonstrations of the software and see how much has been implemented. More rapid delivery and deployment of useful software to the customer is possible. Customers are able to use and gain value from the software earlier than is possible with the waterfall process. Chapter 2 Software Processes. Incremental Development Problems. The process is not visible. Managers need regular deliverables to measure progress. If systems are developed quickly, it is not cost-effective to produce documents that reflect every version of the system. System structure tends to degrade as new increments are added. Unless time and money is spent on refactoring to improve the software, regular change tends to corrupt its structure. Incorporating further software changes becomes increasingly difficult and costly. Chapter 2 Software Processes. 3. Reuse-oriented software engineering. Based on systematic reuse where systems are integrated from existing components or COTS, commercial off-the-shelf systems. Process stages. Component analysis. Requirements modification. System design with reuse. Development and integration. Reuse is now the standard approach for building many types of business system. Reuse covered in more depth in Chapter 16. Chapter 2 Software Processes. Reuse-oriented software engineering. Chapter 2 Software Processes. Chapter 2 Software Processes. Process activities. Real software processes are interleaved sequences of technical, collaborative and managerial activities with the overall goal of specifying, designing, implementing and testing a software system. The 4 basic process activities of specification, development, validation and evolution are organized differently in different development processes. In the waterfall model, they are organized in sequence, whereas in incremental development they are interleaved. Chapter 2 Software Processes. Software specification. The process of establishing what services are required and the constraints on the system's operation and development. Requirements engineering process. Feasibility study. Is it technically and financially feasible to build the system? Requirement solicitation and analysis. What do the system stakeholders require or expect from the system? Requirements specification. Defining the requirements in detail. Requirements validation. Checking the validity of the requirements. Chapter 2 Software Processes. The requirements engineering process. Chapter 2 Software Processes. Software design and implementation. The process of converting the system specification into an executable system. Design is about how to build a system. Software design. Design a software structure that realizes the specification. Implementation. Translate this structure into an executable program. The activities of design and implementation are closely related and may be interleaved. Chapter 2 Software Processes. A general model of the design process. Chapter 2 Software Processes. Chapter 2 Software Processes. Design activities. Architectural design, where you identify the overall structure of the system, the principal components, sometimes called subsystems or modules, their relationships and how they are distributed. Interface design, where you define the interfaces between system components. Component design, where you take each system component and design how it will operate. Database design, where you design the system data structures and how these are to be represented in a database. Chapter 2 Software Processes. Chapter 2 Software Processes. Software validation. Verification and validation, 5 and 5, is intended to show that a system conforms to its specification and meets the requirements of the system customer. Involves checking and review processes and system testing. System testing involves executing the system with test cases that are derived from the specification of the real data to be processed by the system. Testing is the most commonly used 5 and 5 activity. Chapter 2 Software Processes. Chapter 2 Software Processes. Stages of testing. Chapter 2 Software Processes. Chapter 2 Software Processes. Testing stages. Development or component testing. Individual components are tested independently. Components may be functions or objects or coherent groupings of these entities. System testing. Testing of the system as a whole. Testing of emergent properties is particularly important. Acceptance testing. Testing with customer data to check that the system meets the customer's needs. Chapter 2 Software Processes. Testing phases in a plan-driven software process. Chapter 2 Software Processes. Chapter 2 Software Processes. Software evolution. Software is inherently flexible and can change. As requirements change through changing business circumstances, the software that supports the business must also evolve and change. Although there has been a demarcation between development and evolution, maintenance, this is increasingly irrelevant as fewer and fewer systems are completely new. Chapter 2 Software Processes. Chapter 2 Software Processes. System evolution. Chapter 2 Software Processes. Chapter 2 Software Processes. Coping with change. Change is inevitable in all large software projects. Business changes lead to new and changed system requirements. New technologies open up new possibilities for improving implementations. Changing platforms require application changes. Change leads to rework, so the costs of change include both rework, for example reanalyzing requirements, as well as the costs of implementing new functionality. Chapter 2 Software Processes. Reducing the costs of rework. Change avoidance, where the software process includes activities that can anticipate possible changes before significant rework is required. For example, a prototype system may be developed to show some key features of the system to customers. Change tolerance, where the process is designed so that changes can be accommodated at relatively low cost. This normally involves some form of incremental development. Proposed changes may be implemented in increments that have not yet been developed. If this is impossible, then only a single increment, a small part of the system, may have been altered to incorporate the change. Chapter 2 Software Processes. Chapter 2 Software Processes. Software prototyping. A prototype is an initial version of a system used to demonstrate concepts and try out design options. A prototype can be used in the requirements engineering process to help with requirement solicitation and validation, in design processes to explore options and develop a UI design, in the testing process to run back-to-back tests. Chapter 2 Software Processes. Benefits of prototyping. Improved system usability. A closer match to users' real needs. Improved design quality. Improved maintainability. Reduced development effort. Chapter 2 Software Processes. The process of prototype development. Chapter 2 Software Processes. Prototype development may be based on rapid prototyping languages or tools. May involve leaving out functionality. Prototype should focus on areas of the product that are not well understood. Error checking and recovery may not be included in the prototype. Focus on functional rather than non-functional requirements such as reliability and security. Chapter 2 Software Processes. Throwaway prototypes. Prototypes should be discarded after development as they are not a good basis for a production system. It may be impossible to tune the system to meet non-functional requirements. Prototypes are normally undocumented. The prototype structure is usually degraded through rapid change. The prototype probably will not meet normal organizational quality standards. Chapter 2 Software Processes. Chapter 2 Software Processes. For incremental delivery. Rather than deliver the system as a single delivery, the development and delivery is broken down into increments with each increment delivering part of the required functionality. User requirements are prioritized and the highest priority requirements are included in early increments. Once the development of an increment is started, the requirements are frozen though requirements for later increments can continue to evolve. Chapter 2 Software Processes. Chapter 2 Software Processes. Incremental Delivery. Incremental Development. Develop the system in increments and evaluate each increment before proceeding to the development of the next increment. Normal approach used in Agile methods. Evaluation done by user/customer proxy. Incremental Delivery. Deploy an increment for use by end users. More realistic evaluation about practical use of software. Difficult to implement for replacement systems as increments have less functionality than the system being replaced. Chapter 2 Software Processes. Chapter 2 Software Processes. Incremental Delivery. Chapter 2 Software Processes. Incremental Delivery Advantages. Customer value can be delivered with each increment so system functionality is available earlier. Early increments act as a prototype to help elicit requirements for later increments. Lower risk of overall project failure. The highest priority system services tend to receive the most testing. Chapter 2 Software Processes. Incremental Delivery Problems. Most systems require a set of basic facilities that are used by different parts of the system. As requirements are not defined in detail until an increment is to be implemented, it can be hard to identify common facilities that are needed by all increments. The essence of iterative processes is that the specification is developed in conjunction with the software. However, this conflicts with the procurement model of many organizations, where the complete system specification is part of the system development contract. Chapter 2 Software Processes. Chapter 2 Software Processes. 5-BAME Spiral Model. Process is represented as a spiral rather than as a sequence of activities with backtracking. Each loop in the spiral represents a phase in the process. No fixed phases such as specification or design. Loops in the spiral are chosen depending on what is required. Risks are explicitly assessed and resolved throughout the process. Chapter 2 Software Processes. BAME Spiral Model of the Software Process. Chapter 2 Software Processes. Chapter 2 Software Processes. Spiral Model Sectors. Objective setting. Specific objectives for the phase are identified. Risk assessment and reduction. Risks are assessed and activities put in place to reduce the key risks. Development and validation. A development model for the system is chosen, which can be any of the generic modules. Planning. The project is reviewed and the next phase of the spiral is planned. Chapter 2 Software Processes. Chapter 2 Software Processes. Spiral Model Usage. Spiral model has been very influential in helping people think about iteration in software processes and introducing the risk-driven approach to development. In practice, however, the model is rarely used as published for practical software development. Chapter 2 Software Processes. 6. The Rational Unified Process. A modern generic process derived from the work on the UML and associated process. Brings together aspects of the generic process models discussed previously. Normally described from 3 perspectives. A dynamic perspective that shows phases over time. A static perspective that shows process activities. A practice perspective that suggests good practice. Chapter 2 Software Processes. Core workflows. Requirements. Determining what the system should do. Analysis. Refining and structuring the requirements. Design. Defining system architecture to satisfy requirements. Implementation. Building the software. Testing. Verifying that the implementation is correct. A baseline is the result of an iteration, a partially complete version of the final system. An iteration is the difference between 2 consecutive baselines. Core workflows. Fig.2.5, Arlo and Neustarts, 2005. Upstructure. Fig.2.6, Arlo and Neustarts, 2005. Upstructure. Fig.2.7, Arlo and Neustadt, 2005. Phases in the Rational Unified Process. Chapter 2 Software Processes. Chapter 2 Software Processes. RUP Phases. Inception. Establish the business case for the system. Elaboration. Develop an understanding of the problem domain and the system architecture. Construction. System design, programming and testing. Transition. Deploy the system in its operating environment. Chapter 2 Software Processes. Chapter 2 Software Processes. RUP Iteration. In-phase iteration. Each phase is iterative with results developed incrementally. Cross-phase iteration. As shown by the loop in the RUP model, the whole set of phases may be enacted incrementally. Chapter 2 Software Processes. Static workflows in the Rational Unified Process. Description. Business modeling. The business processes are modeled using business use cases. Requirements. Actors who interact with the system are identified and use cases are developed to model the system requirements. Analysis and design. A design model is created and documented using architectural models, component models, object models and sequence models. Implementation. The components in the system are implemented and structured into implementation subsystems. Automatic code generation from design models helps accelerate this process. Chapter 2 Software Processes. Static workflows in the Rational Unified Process. Description. Testing. Testing is an iterative process that is carried out in conjunction with implementation. System testing follows the completion of the implementation. Deployment. A product release is created, distributed to users and installed in their workplace. Configuration and change management. This supporting workflow manage changes to the system, see Chapter 25. Project management. This supporting workflow manages the system development, see Chapters 22 and 23. Environment. This workflow is concerned with making appropriate software tools available to the software development team. Chapter 2 Software Processes. Chapter 2 Software Processes. RUP Good Practice. Develop software iteratively. Plan increments based on customer priorities and deliver highest priority increments first. Manage requirements. Explicitly document customer requirements and keep track of changes to these requirements. Use component-based architectures. Organize the system architecture as a set of reusable components. Chapter 2 Software Processes. Chapter 2 Software Processes. RUP Good Practice. Visually model software. Use graphical UML models to present static and dynamic views of the software. Verify software quality. Ensure that the software meets organizational quality standards. Control changes to software. Manage software changes using a change management system and configuration management tools. Chapter 2 Software Processes. Chapter 2 Software Processes. Key points. Software processes are the activities involved in producing a software system. Software process models are abstract representations of these processes. General process models describe the organization of software processes. Examples of these general models include the waterfall model, incremental, exploratory, development, reuse-oriented development, incremental delivery, BAME spiral model, and RUP. Chapter 2 Software Processes. Chapter 2 Software Processes. Key points. Requirements engineering is the process of developing a software specification. Design and implementation processes are concerned with transforming a requirements specification into an executable software system. Software validation is the process of checking that the system conforms to its specification and that it meets the real needs of the users of the system. Software evolution takes place when you change existing software systems to meet new requirements. The software must evolve to remain useful. Chapter 2 Software Processes.